In this video, we're going to be talking about speech recognition and synthesis. So remember from a previous video, we talked about interacting with the robot. For example, if you ask it to get the water bottle from the kitchen. Now I want to break it down into a couple of steps. So once you speak to a robot, the first step that needs to happen is speech recognition. In other words, what did the human just tell the robot? This has to do with taking, the raw audio that the human has spoken and actually figuring out what words were spoken so that you can then process them. That would be the next step. Based on the words that the human told me, what does it mean? And this is typically known as natural language processing. It's a big field, and for this video, we're going to be doing some very, very simple processing, but you can of course take that further. From this point, once you've processed a speech, the robot can then figure out what it is it needs to do. But also, another important part of human-robot interaction is communicating back to the human the intent of the robot. And you can do this by talking back, and this is formally known as speech synthesis. So you provide some text to speak back, and the robot will play it back. For example, it might say, "Okay, I will search in the kitchen, please wait." So this says two things, right? One, that it correctly understood what you asked it, and two, that you have to wait. So the robot will take some time to go to the kitchen, look for the water. It's good to communicate to a human. So on the raw side, as you see here, I've started both a speech recognition and a speech synthesis node. The speech recognition comes from the RC Home Edu Learn package, which is also available on GitHub, and the speech synthesis is just a standard sound play package in ROS. On the MATLAB side, we'll be working in the speech folder. So first, let's do synthesis, which is a bit easier. Here we'll go to the test's speech action script, and you'll see it's fairly straightforward. Here, we're going to be using ROS actions. In particular, we're going to use a ROS action that's provided by the SoundPlay node called SoundPlay. So I will connect to this, and then I will run the next part of code, which should say the text that I've told it to say in this line of code.
Save text sent from MATLAB.
Okay, so we've proven that we can speak. Now let's talk about the other side of things. I'm just going to very quickly do a ROS topic echo of this topic called lm_data, and this is what's going to be returning all my detected speech from the recognition node that we're running. Hello, get the water from the kitchen. Where is the glass? Is it in the living room? So as you see, the speech recognition is not perfect, but I can start getting some keywords here. So now I've just terminated the echoing of this topic. The idea is that as we receive things on this LM data topic, we want to be able to parse out some of the words and figure out whether we can do something with this. So to do this, I'm going to show you the parse speech command function that I've written. So this is a function that accepts some kind of string, and it's just looking for keywords. So very simple. It might be looking for objects like water, milk, or glass, and it might look for the target location names like kitchen, living, or bedroom. So depending on what you type in, the robot will synthesize a new message. For example, I did not hear a valid object name, and it will speak it back. So first, let me just test this by just typing in a string. I'm just going to copy this function definition here, and I'm going to run it, but instead of passing in a variable here, I'm going to type something. So for example, where is the watermelon? And you see that if I run this, there is no target goal point because I didn't say any of the room names. It picked up the object type as water because I said watermelon, and the output message is I did not hear a valid goal location, which the robot might then speak. If I try it again with a different line, for example, get me milk from the kitchen, then you see it's correctly identified a goal point, an object type, and the output message seems to be correct, so finding the milk in the kitchen. So we'll now show a live demonstration of this with this speech task script, which again, it'll create a subscriber to LM data, which is receiving the detected text, and an action client to SoundPlay. And then in the middle, we're just going to be hearing an audio clip, parsing the speech command, and speaking it back. Please get the glass from the kitchen.
Finding the glass in the kitchen.
Could you get the t-shirt from outside?
I did not hear a valid object name. I did not hear a valid goal location.
Now, another way that you can parse text, in addition to just writing textual code, is by using Stateflow, which is the MathWorks tool for creating state machines. And I want to show you this really quickly. If I maximize this, here now I can create the same kind of logic where I'm checking for keywords, but I can do it in a graphical way. When you enter this chart, you're going to be in the listen state. So you're just going to be waiting to hear some kind of word. And depending on the keywords that you speak, for example, hello will go to the greeting state, stop will go to the stop state and shut off the robot, and anything that contains kitchen, bedroom, or living room will go to another subchart which will do more things. So for example, if I ask for something from the kitchen, you're going to go into this particular subchart where it's going to simulate the robot going to the room, then asking the user for which object it wants, and so on. So you can create these really nice diagrams that will express your logic. So we'll see a demonstration of that as well.
Start on program.
Hello.
Oh, hi there.
Go to the kitchen.
Go into the kitchen. Kitchen reached. Which object should I look for?
How about some water?
Okay, I will get the water. Here is your water. Enjoy.
Stop.
Goodbye.
So now that you've seen both of those examples, hopefully you understand how to do speech synthesis and recognition using MATLAB. Hopefully you can then integrate this with some of the other modules that you'll be developing throughout this challenge.